Hello. Alright, so doing a quick little sound check and it got me. Alright, so we're going to take a look at graphing using reflections. Now, you notice that the adjustment that has happened to each of these is just a negative that has been placed on the outside of the function. It's a negative that's been placed on the outside of the parent identifier. So this means that this is going to be a vertical reflection. Now, let's just take a quick look at why. I'm not going to do this for all of them, but I'm going to use the parabola as the example. But if I put in a -2, and then let's say a -1, 0, 1, and 2, if I put those values in for x, then this is going to give me a -2 squared is going to be a 4. There's going to be a 1, 0, 1, and 4. However, when I tack on a negative outside of the squaring, you realize that that's going to actually insert the negative in front. So for this one, it's going to be a negative here, here, here. So the negative actually gets applied to the y value after we do the squaring. So after we clean up the negative that was inserted for the -2 and the -1, it's still going to be a negative because of the negative that's outside the parent function. Basically outside the identifier that tells us what kind of function it is. So let's go ahead and graph this. I have a negative. You know what? Let me go ahead and put the parent graph on there as a dashed line. Let me put that on. Over 2 up 4. That'll help you to see the change. So there's up over 2 up 4, over 3 up 9. Okay, so here's this. Here's the parent graph. Going up like that. Now we're going to take a look at the one that I just gave us information on, and that's going to be down here. It's going to go down. So I'm not going to have any values that are positive. I'm not going to have any positive values. I'm going to have a non-negative 0, but I'm not going to have any positive. Over 2, 1, 2, 3, 4. And then 1, 2, 1, 2, 3, 4. And it's going to continue to go out to the 9 at 3. And that is my first. Now, let's go to the second one. This one is, we know this to be a cubic function, a cube function. And so I'm going to go ahead and just put the parent graph on here. And that looks like this. Over 1. If I put a 1 in, you know I'm going to get a 1. If I put a 2 in, I get an 8. So let's go ahead and count that up. 4, 5, 6, 7, 8. So there's my dashed parent function. And it continues to go out, and it continues to go up. It's curved. It does come inside where the other one was. So, okay. There's that. So now, with the negative, every point that was above is going to be below, and every point that was below is going to be above, right? So we know that this one's going to go this way. So this is what we have. There. 2, 1, 2. Let's see. 2 and 8. 1 and 1. 2 and 8. There we go. It continues to spread out. And there is that function there. Kind of like a little S serpentine. Okie doke, and let's do this last one. I know that this function here makes a V, right? Absolute value. Function makes a V, and it goes right through the 45 degree angle on your paper. Oops, that's kind of off. Okay, there's that. This one goes right through the 45 as whoops, there it is through there as well. And now we're going to take a negative and apply it to it, and you can see that it just opens down now. That's all it does. Really simple. It's a vertical, we call that a vertical reflection in the x-axis. Vertical reflection. Okie doke. My graph looks like it's a little bit wide. It doesn't look exactly like 45 degrees, but according to the graph paper it is. So hope this helped. Thanks for watching.